Hello viewers, welcome to Add-on. In this question, we will discuss about diode clipper circuit with appropriate example. Okay, so we will want to discuss about clipper. So what is a clipper? Clipper is a device, or we can say the mechanical instrument which removes either the positive half cycle or the negative half cycle, or it can remove both the half cycle. For example, in a sinusoidal waveform like this, there is two half cycle. One is positive half cycle and another is negative half cycle. So if we want to remove the positive half cycle, or if we want to remove the negative half cycle, or if we want to remove both of this half cycle, we will use clipper. Okay. And now this clipper are of three types: series clipper, shunt clipper. This shunt clipper is also known as parallel clipper, and dual clipper. Okay. So these are the three types of clipper circuit. So at first we will start with series positive clipper. And one thing, clipper can either remove positive half cycle or negative half cycle. So they can be either positive clipper or negative clipper. And if they remove some portion of both the positive and negative half cycle, then they will be considered as dual clipper. Okay. So at first we will study about series positive clipper. So the circuit diagram of series positive clipper is like this. So we are applying the input voltage across these two terminals, and across this resistance, we can say the load resistance, we are taking the output voltage. Okay. And this input voltage is AC input voltage, or we can say AC source. Okay. So what happens that this AC source, for the positive half cycle, let us suppose I am drawing it like this again. So for the positive half cycle, the polarities of the battery, or we can say the polarity of the source, will be like this. So the N terminal of the PN junction is connected to the positive terminal, and the P terminal, I am denoting here N and P, and the P terminal is connected to the negative terminal. So what happens here, that during the positive half cycle, the diode, it becomes reverse biased, because the N terminal is connected to the positive pole of the battery and the P terminal is connected to the negative pole of the battery. So the diode becomes reverse biased. So during the positive half cycle, no current will flow within the circuit. And for negative half cycle, suppose here for the negative half cycle, this is the V output. So here, as I have said, no current will flow within the circuit. So V output will be 0. But here, during the negative half cycle, the polarities of the battery will be like this. So during this time, the N terminal will be connected to negative pole and P terminal is connected to the positive pole. So during this condition, this diode will be forward bias. So as a result, during the negative half cycle, current will be flowing within the circuit and we will be getting the output voltage. So for example, this is the waveform which is given to us. If this is passed through a series positive clipper, for the positive half cycle, as I have said, the output voltage is 0. So we will get 0 for the positive half cycle. We will get 0 for the positive half cycle. And after that, for the negative half cycle, as I have said, we are getting the output voltage. So for the negative half cycle, we will be getting the output voltage. So the output waveform will look like this. Okay. So now if we want to do the opposite thing, we want to keep the positive half cycle and we want to reject, or we can say clip the negative half cycle. So during this time, what do we use? We will use series negative clipper. So let us draw series negative clipper. So at first, let us remove this. Okay. So what happens in a series negative clipper. So in a series negative clipper, we will just change the position of the diode. So at first the diode was like this. So here we will just reverse the diode. The diode will become like this and the remaining connection will remain the same. We will be taking the output voltage across these two terminals and we will be applying the input voltage across these two terminals. So for a AC source, suppose this is the AC source. So for the positive half cycle here, this is the P terminal and this is the N terminal of the PN junction. So the P terminal is connected to the positive half cycle and the N terminal is connected to the negative pole. Sorry, the P terminal is connected to the positive pole of the battery and the N terminal is connected to the negative pole of the battery. So during this time, this diode become forward biased. As a result, current will flow within the circuit and we will get the output voltage. But if the input voltage, if we take the input voltage for the negative half cycle, so during this time, the P terminal is connected to the negative pole of the battery and this N terminal is connected to the positive pole of the battery. So during this time, this diode, this diode becomes reverse biased. So when this diode becomes reverse biased, no current will flow within the circuit and V output will be equal to 0. So for a series negative clipper, this is series negative clipper. So for series negative clipper, for the positive half cycle, as we can see, we are getting the output voltage. So for positive half cycle, we will be getting the positive half cycle. And then for negative half cycle, we will be getting just 0. We won't be getting anything. Okay. So in this case, the positive half cycle was clipped and in this case, the negative half cycle was clipped. Okay. So this is everything about series clipper. And next, we will discuss about parallel clipper. Okay. So let us discuss about parallel clipper. So parallel clipper can also be of two types. Parallel positive and parallel negative. As series clipper was serial positive clipper and serial negative clipper, similarly parallel clipper will be parallel positive clipper and parallel negative clipper. So let us first discuss about parallel positive clipper. So the circuit diagram here will look like this. This is the output voltage and this is the input voltage we are applying here. Okay. So during the parallel positive clipper, suppose during the positive half cycle, the P terminal and the N terminal of the PN junction are here. So the P terminal is connected to the positive pole of the battery and this N terminal is connected to the negative pole of the battery. So what happens? This diode will conduct and as it is forward bias, the P terminal is connected to the positive end and the N terminal is connected to the negative end. So according to this condition, this diode will be forward biased. So the current will flow within the circuit. Okay. So the thing arises, the current will be shorted within the loop. Okay. So the current will flow from here, it will go through here and then again it will go through here. We won't getting any voltage across this two terminal. So during this time, V output will be equal to 0. And when we are using negative half cycle, I'm explaining here. When we are using negative half cycle, the polarities become like this. Okay. So during this time, the P terminal is connected to the negative end of the battery and the N terminal is connected to the positive end of the battery. Okay. So according to this condition, this diode, this become reverse biased. So as this diode become reverse biased, this circuit becomes open. So during this time, this circuit becomes like this. So this diode acts as an open circuit. So the voltage that we are getting at this particular point, suppose V in for the negative half cycle, we will be getting that particular voltage at V out here. Okay. So during this time, we will be getting output voltage. So suppose the sinusoidal input waveform was like this. This is the positive and this is the negative half cycle. So here the output voltage, as we can see during the positive half cycle, the output voltage is 0. So for the positive half cycle, we will be getting 0 at output, and for the negative half cycle, we will be getting the output. Okay, so this is parallel positive clipper. And next, if you want to discuss about parallel negative clipper, so parallel negative clipper, parallel negative clipper. So the circuit diagram of the parallel negative clipper is like this. This is the V out. This is the input AC source, V in. This is a resistance and this is a diode. So during positive half cycle, the N terminal, this N terminal is connected to the positive end of the battery. And this P terminal is connected to the negative end of the battery. So according to this condition, this diode will become forward bias. So when this diode becomes forward bias, current will flow within this loop. Okay. So current will go like this, it will enter the diode like this, and it will go like this. So the diode conducts, as a result, the current will be shorted within this loop. We won't be getting any output voltage here. Okay. Sorry, I think I made a mistake. I have just, let me clear it. During parallel negative clipper, this is the input voltage V in, this is the diode, and this is the resistance. So for the positive half cycle, okay, the N terminal is connected to the positive end of the battery, and the P terminal is connected to the negative end of the battery. So as we know, if the P terminal is connected to the positive end, then the diode will be forward bias. If the P terminal is connected to the positive end and the N terminal is connected to the negative end. Okay. So according to this condition, this diode will be forward biased. But if the P terminal is connected to the negative end and the N terminal is connected to the positive end, then this diode will be reverse biased. So according to this condition, this diode will become reverse biased. So what happens? This diode will not conduct and it will act like a open circuit. So when it will act like an open circuit, the circuit becomes like this. It becomes open at this particular point, and we will be collecting our output voltage across this two terminal. So the input voltage which we are getting across this two terminal, this input voltage we will get this same input voltage across the output terminal. Okay. So during the positive half cycle, we will be getting the output voltage. But during the negative half cycle, this is the N terminal, this is the P terminal. P terminal is connected to the positive end of the battery and the N terminal is connected to the negative end of the battery. So according to this condition, this diode will become forward bias. So if the diode becomes forward bias, this diode will conduct. So if the diode conducts, current will flow within this loop. So it will flow like this, and like this. So the current will become shorted within the loop. And if the current becomes shorted within the loop, at the output side, we won't be getting any output voltage. So for the input sinusoidal waveform like this, as we know, for the positive half cycle, we are getting the output. So the output we are getting at the output of this parallel negative clipper, we will be getting the positive waveform. But for the negative half cycle, we won't be getting anything. We will be getting 0. Okay. So this is the main concept behind parallel negative clipper. Okay. Now, if you want to understand about dual clipper, let me explain like this here. So, dual clipper, the circuit diagram of the dual clipper is like this. Okay. So this is diode 1, this is diode 2. We are applying the input voltage here, V in. This is external bias voltage, which is V of B1, positive negative terminal. And this is the external bias, V of B2, negative positive terminal. Okay. And this is the V out from here. Okay. So what happens here is this. So this is the V in. Okay. So at this P end of this, so this is the P terminal, this is the N terminal, and this is the N terminal, and this is the P terminal. So at the P terminal of this diode, at this particular point, the voltage is V in. Okay. And at this particular point, at the N terminal, the voltage is VB1. Okay. This is V in and this is VB1. And now, if V in, this is greater than VB1, okay, then the diode 1 will be forward bias because the P side will be connected to the more positive end than the N side. Okay. So during this time, this diode will be forward biased. But if the opposite case arises, if VB1 greater than V in, then this diode will be reverse biased because N terminal will connect it to the more positive end than the P terminal. So during this time, this diode will be reverse biased. And as we have seen from the parallel clipper, when the diode becomes reverse biased, we will be getting the output voltage. Okay. So suppose I am defining the positive bias voltage here, V of B1. Sorry, it will be somewhere in the upper portion. So if we define the voltage V of B1 here, so as long as V of B1 is greater than V in, then the diode will be reverse bias. So suppose if the input voltage V in is like this, so up to this point, the diode will conduct for the positive half cycle. Okay. Up to this point, the diode will conduct. And then for the negative half cycle, if we deal with the negative half cycle, here we will be getting V in of negatives for the negative half cycle. And for the positive half cycle, this was V in of positive. Okay, so this is V in of negative. And at this point, this was the N terminal. At the N terminal, we are getting V in of negative. And at the P terminal, we are getting VB2 of negative. Okay. So if V in of negative is greater than VB2 of negative, then the diode will be forward biased because the N terminal is connected to a negative terminal. Okay. So as we know, if the N terminal is connected to the negative terminal, then the diode will be forward biased, and the P terminal is connected to the positive terminal, then the diode will be forward biased. So here, if V in negative is greater than VB2 negative, then the diode will be forward biased. But if VB2 negative is greater than V in negative, then the P terminal is connected to a more negative voltage bias, or we can say more negative voltage than the N terminal. So during this time, this diode will be reverse bias. So as we know from the parallel clipper, this structure or this circuit will only conduct if the diode becomes reverse bias. So if V2 negative is greater than V in negative, then the diode will be reverse bias. So suppose in this waveform, I am defining VB2 negative here. So up to this point, the diode will conduct. So it will go like this. This waveform like this. Okay. So for this input waveform V in, this is suppose V in of positive, and this is suppose V in of negative. Okay. This is V in of negative. So this is V in of negative, this is V in of positive. So up to VB1, we will be getting the output voltage, and up to VB2, we will be getting the output voltage. Show the we can say the top of the positive peak and the negative peak of the input voltage will become like this flat like structure, or flat will become flat at the output of the dual clipper. So it signifies that it has clipped some portion of the waveform at the positive half cycle, and it has clipped some portion of the waveform at the negative half cycle as well. So as it is clipping the waveform in both the positive half cycle as well as negative half cycle, so we are naming it as dual clipper. So this is all about clipper circuit. Thank you.